So my name is Rafael Saavedra, and I'm the VP of Engineering and also one of the founders of RightScale, so I've been there from the very beginning. What I'm going to basically show you is the kind of functionality or tools or features that we provide so that you can basically optimize your application on RightScale. So more than focusing on the actual act of optimizing an application, is more what kind of tools we provide to you and that you can use in order for you to basically start on the path of optimizing applications. And some of these tools and features are the ones that we ourselves use to optimize RightScale, because as you know, we run RightScale on RightScale itself. Okay? The agenda is I'm going to present a brief introduction, and then I'm going to basically talk about the three-tier application architecture, something that all of you most probably are very familiar. And then I'm going to basically touch about how you do vertical and horizontal scaling. It's a little bit maybe for you basic in terms of if you're already familiar with cloud computing. It's something that you already know. And then the support that we give for monitoring alerts and escalation on RightScale, and then going more into the new kind of monitoring graphs that we're providing for our users, basically cluster graphs in which we have two examples that we're basically using ourselves a lot, and we're basically encourage our users to start exploring them. That is stack graphs and heap maps. Then we're going to present basically a third-party tool that is New Relic, and there is an integration in the dashboard that allows you to connect to New Relic and basically go deeper into what is the performance of your application. And we have found it very useful ourselves in improving the performance not only our database, but also in our Rails application. And then finally, we'll touch a little bit about support for optimizing DB performance, some examples or general rules or general advice that we have, and in the end, some miscellaneous comments. So let me start by saying, well, what are the cloud computing characteristics? And it's something that people have touched in the morning, but I'm just going to basically say this has to do with multi-tenancy. Also, it's the idea of pooling shared resources, in which basically all the resources are there for the community or for everybody to use. And the advantage is that when there is more demand coming from one customer, he can have access, because that basically is using the large number benefit, that is someone else is not using this resource at the same time. So the other one is basically having a geo distribution and ubiquitous network access. And the idea is that you can have resources around the world. And for example, with AWS, you can have basically cloud resources in Asia, in Europe, and in the United States, and in multiple locations. And in each location or region, you also have basically different zones. So it's service-oriented in the sense that basically they provide an API, and you make calls, and it's on a service API base. And the idea of dynamic resource provisioning, it's something that we understand, is you can ask for resources anytime you want, and you only pay for the time that you need them, and you can basically give them back when you don't need them. And then it's self-organizing and utility-based pricing, and that's basically the good things about cloud computing. The advantages is, well, we're no upfront investment, lowering operation cost, highly scalable, easy access, and reduces the business risks and maintenance cost. And now the kind of applications that I'm going to focus on is basically what most people are probably using the cloud. If it's not for weak computing, it's a three-tier application in which you have basically a layer of load balancers, and behind that you have maybe an array of app servers that you want to scale horizontally, and also behind that you have a master-slave kind of replication. You may have something more complex. You may have maybe multiple slaves that you're using for reads, but and these basically master and slave are using EBS to do a snapshotting, and then maybe sending it also to long-term storage that may be S3 in the case of AWS. Okay? So it's something that you guys should be very familiar. And so the dimensions of doing cloud performance optimizations that you have basically easily available through the dashboard in RightScale is you can do vertical scaling. That is that you can basically change your application and go to a server that has more capacity. It's easy for me to ask for a bigger server. So that notion, it's basically translated to the cloud very easily. What is something that is more cloud-based is the notion of horizontal scaling. That is that once I know that an application runs in a way efficiently in one instance type, what I want, for example, for an app server is to replicate that. So instead of adding more resources vertically, maybe more CPU, what I want is to have just more servers. And that's easily doable. And we have spent sometimes basically the notion of a server array is what you use in RightScale to rapidly scale horizontally. So we're going to touch about that. And then we also have functionality that allows you to support performance optimization by providing to you server templates that are configured to capture performance data. So something that we do is that every server template that we publish and we make available to our customers, all of them have already been basically configured by using either write scripts or recipes to collect performance data using collectd, send the data to our servers. We have a farm of hundreds of servers that basically what they're doing is capturing terabytes of data from the tens of thousands of servers that are running, managed by RightScale, and we make that available to you through basically the monitoring graphs that you have either on a server level, on a deployment, or even at the hold and in your account. And you can look at them at the very different dimensions. So as I mentioned, we have collectd write scripts in which we capture hardware and operating system monitoring data. At the same time, we have specialized plugins that we put in our server templates depending on the type of template, either if it's an HA proxy template. So we have a specialized HA proxy plugin that is capturing basically performance data that has to do with request, with the status of the different threads, and so on. At the same time, for MySQL, we also have a MySQL plugin that we provide. And in that case, you can monitor in a lot of detail the performance of your database. And we do the same thing for Apache and Nginx. And we have the new server templates that are Windows-based, for example, IIS. And we are also writing these plugins, and we're going to continue doing that in the future. So we give a lot of importance to the capturing of data and displaying the data. In addition, we are doing more work in displaying that information with individual monitoring graphs and with a new cluster stack and heat maps. And I'm hoping that some of you are using it. And if you're not, basically, I'm gonna give you an introduction of them. And once you have the data, we connect that with alerts and escalation so that you can notify when the performance of your servers basically is going below the threshold that for you is acceptable. And you can get alerts, and then you can connect these to escalation so that you can respond either by launching more servers. You may be rebooting if your server is basically have some problems and so on. And in the end, I'm going to talk about how the use of something that is not RightScale, but that we try to basically integrate with the dashboard, that is the use of a third party that is New Relic. So how do we provide scaling up? So well, the good thing about working on the cloud and is basically using the resources that someone like AWS, Amazon provides, is that you have a large spectrum of different instance sizes. And some of them are basically optimized for memory, and others are optimized for CPU. And if you are willing to pay more money, you can have a combination of both. So here, what I'm showing you, this is based on AWS, is the instances that are currently available for you. And what we have here is compute units, and these compute units are basically the same what Amazon publishes on the website against memory size. And you can see that what you have is you can identify different regions that in which you can always find a collection of instances that it makes sense for you to start using it and to exploit. And if you need to start growing vertically, because the performance of the instance that you're using right now is not what you need, you can basically have a path. And maybe the one that provides the wider spectrum is the one in which you can start with a N1 small and then basically climb to an N1 large. And if you need more memory, you can go to an extra large. And then these ones are basically more very, very large memory and more, and the CPU increases because you have more cores in them. So all this region is basically the path in which you can go from less, well, I think it's 1.7 gigabytes of memory to up to something that is more than 66 gigabytes of memory. And for things like, for example, a database, if you haven't sharded your database and you still have a single database and a single box, well, that's the only path that you can follow, that is just put more resources. And at some point, when you reach this point, you have to start thinking about either removing services away from your database or also sharding your database. And it's something that we ourselves are basically facing, in which we, maybe 6 months ago or maybe a year, we were maxing our database even with the quadruple extra large. So what we've been doing actively is to basically break our application into a collection of services that we can deploy independent of each other, and that basically each of them has its own database. In some cases, we're using NoSQL, we're using Cassandra, so that we can provide a ring in many different locations. But the idea is that instead of having a single point of failure and a single database that just grows and grows, we're breaking into smaller pieces. Now, if your application is more very computing intensive, either because you're doing some transcoding on graphics, well, you also have these very beefy instances in which you can basically go from this to that one and have a path to do that. And the new micro allows you to, in a very cheap way, to basically spawn a lot of servers and pay little money. Obviously, the performance is much limited than in other cases. So once you have explored scaling up, what you want is, well, you really want something that is an application that grows in terms of usage. You want to scale horizontally. And for that, what we offer is the notion of a server array, that what you can do is you can put your application servers in a server array. You can connect them. You can connect them maybe through alerts and escalations, and basically vote based on some performance threshold metric, so that if the performance goes below a certain value, you can the servers themselves start voting to basically launch new servers, and you can do that, and basically you can use a combination of techniques, either tags. You can use the notion of tagging, in which you can set the set of servers that are the ones who are going to decide what is the criteria for you to scale up and scale down. And these can be an arbitration decision set. It can be servers in the array, or servers who are completely outside of the array, but maybe are your HR proxy who can decide that. It depends on you. At the same time, the decision threshold controls the reaction time, and you can be aggressive or conservative based on your basically how much money you are willing to pay. You can put a very conservative threshold that is going to launch servers even before you're going to need them, just at the very early indications that the load is increasing. And if you're willing to pay maybe the extra hours of ramping up, well, you can have the servers ready. And also, at the same time, you can be very conservative in turning these servers off by just basically changing the threshold. If you want to minimize the money, well, you can be more aggressive. Obviously, if suddenly you have a ramp up in demand, it may be that your servers are not going to be able to catch up. So, but you can control that easily. We also introduce the notion of a sleep time, and the idea there is that if you launch some servers, what you want before making a new decision about launching more servers onto scaling, you want to see the impact of the servers that you just launched. And the sleep time, basically what it says is that you wait some time for the new resources to be online, and that these resources to start taking traffic, so that you can measure what is the response after this decision point has been made. And after that, then you can make a new decision point. And again, you can be aggressive or not, depending on your application. We also have scaling can be time dependent. We put that notion in which you can basically schedule the launching of servers and also terminating them based on some pattern that you see day to day. There are some applications in which the pattern is very, very, very predictable. I think one of our customers present that application today about the schools. The schools, basically, during the day, they are active, and then after school hours, basically, the servers are not needed anymore. So in his case, he's very fortunate that it's a very predictable pattern that has to do with basically the working hours, and he can basically capture that on the arrays. So we provide a lot of documentation in our support portal that basically explains in detail how to set things up. So if you are not familiar or you haven't used our support portal, I encourage you to go and read all the tutorials that we put there. We try to come with new tutorials every couple of months, so that we really want to explain the complexity and basically remove the complexity from using our features. And we try to go in a lot of, as you can see all those links, into a lot of detail in how to configure these different the server arrays, how to program them, how to use them, what are the best practices. And we also give you, I think it's on this one, a lot of information on how to use our dashboard, but also best practices. So please, it's something that you should be using and giving us feedback, because it's clear that our dashboard, and it's not something that is easy to learn for beginners. It's something that we accept. It has evolved over time, so not necessarily is the most intuitive. So we need a lot of feedback from you guys through this from the support portal, so that we can improve these things. So the benefits from using arrays is that we can have a fast response to changes in load conditions using alerts. Allocation of servers to availability zones is based on weights. I don't know, it's something that I did some statistics looking at our database, and what I'm finding is that very few people are using weights to really control how you distribute your servers in different availability zones. Something that has been maybe a recurrent theme in this morning is what happened with Amazon with the outage, and how some companies were able to withstand the outage by basically deploying their servers in the right availability zones. It's something that we provide the notion of weighting, random weights, that basically you decide whether you want to use 1, 2, 3, or 4 availability zones, and then you can how to distribute your servers so that you have a good balance, and that in case that one availability zones go down, basically you have enough resources so that you can recover. Again, it's a trade-off between money and resources. You can always put enough resources, for example, in 3 out of 4 availability zones, so that if a complete zone goes down, you can still basically give good service to your customers. What you do is that you have basically a cushion of, let's say in this case, 33%. If you have extra 33% by using an extra availability zone, well, if one of them goes down, you still have enough resources. Now, if you are not willing to pay that much money, then you can reduce that and maybe have a cushion of maybe 10% or 15%, that if one of the availability zones go down, your performance is going to suffer a little bit, but that will allow you time to launch new servers in the same available zones and then basically recover back. So the other thing that I think we found extremely valuable with server arrays is that because server arrays are attached to a deployment, once you can configure your servers, basically your inputs in the deployment, those inputs are inherited by the server array. So you may have some static servers for your application, and also you can spill out into an array, and you can guarantee that whatever servers you are launching in your array are going to be configured exactly the same as the ones in your deployment, because they share the same notion of the inputs. So that's something that is very advantageous. And then, as I mentioned, arrays can be pre-scaled to support anticipated demand. And the example that we have seen here is that some companies are doing some promotions. So they know that, for example, in 3 days we're going to have a promotion. You can launch your servers ahead of time, and make sure that all these resources are basically available and ready to from the get-go. Okay. Okay, so let me talk about cluster monitoring and something that we found very useful. And here is that we have individual graphs that you can manage as a unit. So for example, you can have all these little graphs for your application servers, and you can put it all together so that if you scale the time on one of them, all of them basically scale at the same time. And if you change the dimension, so now you have to look, you want to look at maybe this time, basically all of them change at the same time. So that we have been providing that for more than a year, and they're very useful. The problem with using these individual graphs is that once you reach maybe 20 servers or maybe 30, and then you go to 100, it's basically impossible to look at these 100 graphs and make some conclusions, especially when each of them is contributing to the overall performance. So because of that, we introduced the notion of what is called a stack graph. And a stack graph is that we take the individual components and we put them together in one single graph, and we basically assign a color so that you can distinguish between the contributions that each of them is making. Now, this is very valuable to look at aggregate performance. So for example, to see how the collection of all servers are basically contributing, but it's difficult to distinguish whether one server is being overloaded while another one maybe is underutilized. And that's why we have the notion of heat maps. And the idea of the heat map is to display all these maybe hundreds of servers, but using colors to identify which servers are being overtaxed and which servers basically may not be used. Okay, let me show you some examples of that. So this is the case that I mentioned before, is that the cluster monitoring, it's great when you have something like 8 graphs, but it's easy to see what each server is doing. In this specific case, you can select the servers by either by name, template, or by tag. So in your deployment, you can say, if you already have tagged your applications with maybe the tag apps, it's easy to say, give me all the servers with this tag. Maybe you have tagged your servers, your database servers with DB, so you can basically collect them. Or you can do that based on the server templates, and then you can display them. You can, in one single control, you can say, okay, show me the CPU for all of them. And by changing the metric, it will change on rapidly. And it's easy to see that here, and as an example, you have 8 servers. 6 of them are basically taking normal load or normal activity. One of them, who has been running maybe for a couple of days, seems not to be connected. And then this one, well, probably we just launched it a couple of hours ago. So that's convenient. But again, what is not clear is to say, well, at this point in time, this point relative to this point, maybe these different hours, is the aggregate performance the same or different? In this particular server, they look the same, but it's difficult to make basically the arithmetic for all of them. So if we use an aggregate stack graph, then you have all the contributions put on top of each other. So you can see how things change across all the servers, and even as new servers are added, basically you're going to see the contributions on all of them. You can identify each of the servers by color, so you can know exactly what each is contributing. And you can see that the load is evenly distributed across 6 out of the 8 servers, because you have basically 6 of these different colors here. Okay? Now, if you want to distinguish between this server and this server, it's difficult to do it here. So that's why the idea of a heat map. The idea of a heat map is you have the time dimension here, and then the servers, basically each of them is taking one track of the graph, and then we use colors and some kind of a spectrum of different intensity to tell you whether you are at the upper limit or the lower limit of a range of values. So in this particular case, you can see that Wednesday during the day, all of them are basically highly utilized. During the nights, all of them uniformly are underutilized. That's what you expect. And that this server itself basically has been idle for most of the time. Okay? So, and we use it every day. And we have found a lot of bottlenecks and problems by just using these graphs. And let me give you an example. So this is an example of a heat map of 100 servers. These servers that we use to the farm to collect the statistics. So because they are basically capturing massive amounts of information and also sending a lot of information to as many dashboards people are using. There is a lot of utilization. Also, the more servers you use, the probability that one of them is going to fail increases. So we need to be basically monitoring these servers. And these graphs is interesting because it allows us to find basically a bug in our software. And the reason was that, as you can see, the utilization on the servers here is pretty uniform. And suddenly, at some point in time, 6 of the servers suddenly become overloaded at the same time. And what we discover is that some of our users launch more than 100 servers in a single command. And we have an allocation algorithm that says, well, given the farm of sketchy servers, we have to assign them so that we distribute the load. Well, what we found is that we have some problem. We have some delay in saying, well, if you send some servers to a collection of sketches, you have to wait to see the effect of the new load on these servers before you can basically allocate more servers there. The only problem is that if you launch 100 in the same instance, well, all of them were available at that window of time. So what happened is that a small collection of servers received maybe 20 or 30 or 40 servers. They were put in offline for some period of time, but they already received a very high load. And what we're seeing here is the effect of that high load. Okay. So basically, it exposed some limitation of our allocation algorithm, and it was very convenient to do this, and we have to change that. So as you can see here, it's 60,000 data points that we're displaying. So the amount of information that is shown, it's massive. These 100 servers are also monitoring themselves. So this is the problem. Okay, our monitoring servers are running on EC2, and they're managed by RightScale. Well, we need to monitor these servers in order to see the performance. So we need either themselves or other collection of servers who are also collecting data. And this is an example of the same problem, but then using stack graphs. Basically, what we're doing is you can see how the load increased dramatically at one point in time. So at the macro level, it's easy to see the changes in their overall performance, but at the micro level is difficult, and that's why the combination of both the heat map and the stack graphs is very useful. Okay. So now the cluster monitoring architecture, the way it works is that we have, for example, in your case, you have all your servers here who are sending monitoring information to this collection of servers that we keep. And then we have another set of servers that are basically taking the information for a specific heat map or maybe stack graphs and aggregating it and producing a single graph. So now let me change and talk about New Relic. That is the other tool that we use a lot for performance enhancement and optimization. And the idea of this tool is it's a real-time application performance analysis. It supports Ruby, PHP, Java, and also .NET. And it also has support for SQL and NoSQL performance. And it has a lot of graphs that allows you to trace web transactions and go in very detail until you can find the specific lines that basically are generating either expensive queries or consuming time. And also give you some availability monitoring, gives you basically the availability of your servers, and allows you to do some scalability analysis of your application. We make this from the dashboard in RightScale. You can connect to New Relic. If you haven't used that, if you go to the Reports tab, on the Reports tab, you're going to see a submenu item that is new Relic RPM. And if you have an account, you can basically put your credentials on that page. And once you have set your credentials, what you're going to see is an actual download of your initial page on New Relic displayed on RightScale. As I mentioned, it's historical statistics over a period of time. That's also it can give you distribution of the most time-consuming requests. For example, this period of time is showing you that the deployment show servers is the one that is consuming 9.3% of the time during this period. And you can basically click on this area, and then it's going to go to all the traces for this particular command that has been collected over this period of time. And you can see the distribution. You can go deeper and identify how many, for example, queries you're making to your database, what is the time-consuming, the most time-consuming ones. You can also have statistics about responses times across the world. So for example, in this particular case, it's showing you the distribution of response times as your users in India or Australia or Japan or different parts of the world. And then you can go and also see the specific queries that they are making and try to identify why the performance difference between the different parts of the world. Similarly, you can have detailed response times by browser. So if you can see, for example, whether there is some significant difference between the different browsers. The kind of information that we provide in MySQL, we provide a lot of statistics and some general considerations about your schema, how to basically improve the use of slow queries and how to basically identify why there are performance penalties. And the other thing is that we also provide in our in the library, in the marketplace, some server templates that allow you to do some load testing on your servers. And well, I encourage you to use that. One in particular is httperf that allow you to set up basically a load front end so that you can basically send traffic to our application servers and you can monitor the response times. And in summary, it's performance monitoring data provided at multiple scales to RightScale, either as a server deployment and account, react to performance issues through monitoring alerts and escalations, and it's easy with RightScale to scale vertically or horizontally through auto-scaling, and we're working with third-party providers so that we provide more value added from the point of view of improving your performance. It's something that is not our core competence, but we're basically partnering with other companies, especially SaaS companies, so that we add more functionality to our platform. And again, a lot of the things that we are using ourselves, we're trying to pass that to our customers and users through the use of the marketplace by creating new write scripts, recipes, or server templates.